Okay, an airliner carries 50 passengers and has doors with a height of 72 inches. Heights of men are normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches. Okay, question number 1. If a male passenger is randomly selected, find the probability that he could fit through the doorway without bending. Okay, so for part A, we're looking for a single randomly selected male passenger, what is the probability he is less than 72? Okay, I'm going to come over here to Excel. Okay, so we have the fact that the population of male heights are normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches. And we want to know what is the probability that if one randomly selected male will be less than 72 inches. So we're looking for the probability x is less than 72, or the area to the left of 72 on the normal distribution. Okay, so over here, I just set this up to answer the information from the problem. So we're given that the mean is 69 inches. The standard deviation is 2.8 inches. And the x value we're looking at here is 72. Okay, so for part A, we want to know this. What is the probability that x is less than 72 inches? Let's leave it like that. Okay, so we'll use the normal distribution function in Excel. So we have equal norm.dist. Remember, this function gives you the area to the left of an x value. And area equates to probability. When we're dealing with continuous probability distributions, area and probability are the same. Okay, so our x, and you could type these numbers in directly if you wanted to. Either way, our x value is here in B1. Our mean is here in B2. Our standard deviation is here in B3. And for the cumulative, we always say yes when we're dealing with continuous data. Okay, so it looks like 0.8580. So one randomly selected male has just under an 86% chance of being able to fit through the door without bending down. .8580. Okay, looks good. Now, question 2, part B. If half of the 50 passengers are men, find the probability that the mean height. So what is the probability that for a sample of 25 men, the sample mean is less than 72 inches? This is an application of the central limit theorem. Okay, so we'll apply the central limit theorem here. We have n, the size of our sample is 25. And now we're looking not for a single adult male being 72 inches or left, but an average, a sample average. So x bar is 72. Now, when we're using the central limit theorem, we have to convert to z-scores. So remember, our formula for with the central limit theorem, when we're converting, when we're converting to a z-score, we're using the fact that the mean of the sample means is equal to the population mean, and the standard deviation of the sample means is equal to the standard deviation of the population divided by the square root of n. So our formula for z-scores becomes x bar minus the mean divided by standard deviation over the square root of n. Okay, so let's plug these values into that formula. here under z-score. Okay, so equal. I'll do the numerator in parentheses. So we'll basically, when we're putting this into Excel, we'll put the numerator in parentheses, the denominator in parentheses, so we preserve order of operations. So we have x bar minus the mean, close parentheses, okay? So that's the numerator, divided by, in parentheses, the standard deviation divided by the square root of n. So that's SQRT for square root of n. Okay, let's close those parentheses. Okay, so now we have our formula for z-score with the central limit theorem. And we should get a larger z-score, yeah, a much larger z-score than we would have gotten with a single value of 72. Okay, and so now we've converted to z-scores. So our mean is 0, and our z-score is, it's about 5.3, if we round it to two places, it's about 5.36. We don't have to round, we'll just use this value in Excel. So the probability that x bar is less than 72, or that the average, the sample average of those 25 passengers is less than 72, well, we'll have to use not the normal distribution function, because now we're using z-scores. So it's the normal standard distribution. So norm.s .dist. Oh, don't forget the equal sign. And we need to tell Excel what our z-score is. It's here in B7. And for the cumulative question, always 1, always yes for continuous data. Okay, and if we were to round this to 4 places, we would get 1. Let's do that. Our directions say round to 4 decimal places. Okay, so the probability that the average of those 25 men being less than 72 inches, well, when we round to 4 decimal places, it's 100%. So just 1. Now, excuse me, when considering the comfort and safety of passengers, which result is more relevant, the probability from part A or the probability from part B? Well, I would say the probability from part A, because in part A, we're talking about the probability of an individual randomly selected male is about 86%, 85.8%. And so that's what part A is telling us, is that 85.8% of all men should be able to fit through the door without ducking down. We're not concerned about groups of 25 and on average how many of them, we're talking about individual men. So the probability from part A is more relevant because it shows the proportion, or percentage, same thing, proportion of male passengers that will not need to bend. Yeah, I'm definitely leaning towards A. The probability from part B is more relevant because it shows the proportion of flights where the mean height of male, no, definitely not. We're not talking about proportion of flights. We're talking about individual people. The probability from part B is more relevant because it shows the proportion of male passengers that will not need to bend. No, option C is out because this is not telling us anything about individuals. It's telling us about groups of 25. We're not concerned about that. We're concerned about each individual male. And the probability from part A is more relevant because it shows the proportion of flights where the mean height. No, again, we're not talking about proportion of flights. Okay, so yeah, it looks like part A, or option A, sounds good to me. All right. And now finally part D. When considering the comfort and safety of passengers, why are women ignored in this case? Well, generally women are shorter than men. on average, not individuals, but on average, women are generally shorter. Okay, so since men are generally taller than women, it is more difficult for them to bend when entering the aircraft. We're not worried about the difficulty of bending, no. Since men are generally taller than women, a design that accommodates a suitable proportion of men will necessarily accommodate a greater proportion of women. That sounds good. I mean, that's basically saying since men are taller, if it works for the men, it's going to work for the women. And C, there is no adequate reason to ignore women. A separate statistical analysis should be carried out for the women. Well, no, because on average, men are actually taller. So they're, yeah, definitely I would go with B for this one. All right, fantastic. All right, so that about does it for this problem. Hope this was helpful.